The final topic of this section, and we're going to break this into two videos, is finding powers and roots of complex numbers in polar form. So this video is going to focus on finding powers of complex numbers in polar form. So we're going to start with I'm going to say it wrong, de Moivre's theorem. I'm just going to leave it at that. So if you have z equals r cosine theta plus I sine theta as a complex number, then z to the n equals r to the n cosine of n theta plus I sine of n theta, where n is a positive integer. So evaluate the expression 1 plus I to the fifth power using de Moivre's theorem. Say that multiple times. Okay, so the first thing we're going to do is put this in polar form. Now, we could just graph this. This is a convenient one to graph because there are 1 and 1. So I think you can see pretty easily that this angle is pi over 4. If you weren't sure about that, tangent theta would be 1 over 1. So theta would be tangent inverse of 1, which is going to be pi over 4. Likewise, r is going to be the square root of 1 squared plus 1 squared, which is going to be square root of 2. Okay. So our complex form for this 1 plus I to the fifth power is going to be the square root of 2 to the fifth power times cosine of 5 is the power, so 5 times our pi over 4 plus I sine of 5 times pi over 4. Okay. And just to kind of give you the reference, this is 1 plus I is the square root of 2 times cosine of pi over 4 plus I sine of pi over 4. Okay. So we have, basically we have 2 to the 5 halves power times cosine of 5 pi over 4 plus I sine of 5 pi over 4. So this is like saying 2 to the fifth and then the square root, so like the square root of 32. 2 to the fifth is 32 times cosine of 5 pi over 4 is negative square root of 2 over 2. I sine, so then I times sine of 5 pi over 4 is negative square root of 2 over 2. So this square root of 32 is 4 times the square root of 2. And then we multiply that through negative square root of 2 over 2 plus negative square root of 2 over 2 times I. So that'll be 4 times the square root of 2 times negative square root of 2 over 2 plus 4 times the square root of 2 times negative square root of 2 over 2 I. So what we have is square root of 2 times square root of 2 is 2, so that would cancel the 2 down below in both cases. So the negative is still there. Negative 4 minus 4i. That's what I get as a final result. Okay, that was kind of fun.